So lesson 2.6 for geometry. Yesterday we talked about some of our properties, our addition property and our subtraction property, right? And we call them properties because they're theorems, but you can't do a converse. Instead, the subtraction property is the converse of the addition property. So today, you've probably guessed that we're going to hit the other two operations, which is the multiplication and the division properties. So that's going to be our focus for today, is how do we apply these multiplication and division properties of segments and angles. Some things that you probably know already, but just how do we say them for sure? How do we use them in proofs? So that's going to be our goal for today. So our warm-up is kind of pulling something that you've done before and kind of linking it up to our lesson for today. So you've got two segments there, split up a little bit. So big segment WZ, big segment LQ. In your given, it says that points X and Y trisect segment WZ. Now we've talked about what trisect means before, so hopefully you remember. It says points M and P trisect segment LQ. It also says that little segment WX is congruent to little segment LM. And your job is to write down everything that you know in your conclusion there. What can you know for sure about that picture based off of those givens? So a little bit more practice drawing those conclusions as well. If you haven't given this a shot yet, go ahead and pause your video and see what you come up with. Okay, so what I see, let's see, the word trisect means three congruent parts, right? So if X and Y trisect segment WZ, that means these three segments are congruent. You could have that listed in your conclusion, those three segments written out as congruent for sure. That would definitely be one thing. And then we have that points M and P trisect segment LQ, so that means these parts are congruent as well. And then our third given says that little segment WX is congruent to little segment LM. Well, that is this segment congruent to this segment. So that means they should be marked the same, right? So instead of one marking over here on WX, whoops, I should really have two markings over here on WX. Oh, but then if I have two markings on that one, I should have two markings on all of these, right? Okay, so technically all of those are congruent, right? But let's think about what we kind of were doing yesterday, where we were combining some parts that maybe we wouldn't really have thought of before. So, well, what if I put a variable in here? What if I say this, like is any measure at all, X, right? Well, then this is X and this is X, but so is this and this and this, right? So how long is this whole big segment? Well, that would be 3x, right? Or whatever that measure was, times 3. Same thing over here. This would also be 3x. So if I know that they're both trisected, and I know that I have one of those little parts on each are congruent, then I know the whole big parts are congruent as well. So the biggest conclusion we could make from that from those givens is that big segment WZ is congruent to big segment LQ. Now, you might think that that's kind of addition, right? Except two congruent parts added to two congruent parts? Well, not really, right? I only knew one part was congruent, and that was these guys over here that were in our givens, but I didn't have a second part congruent, right? What I did was I knew, well, I have this word trisect for both of them, and trisect means that those three parts are equal. So I could take this one part that I knew and multiply it by 3. And the same thing over here, one part that I knew and multiply it by 3, and those big parts would also be congruent. So your warm-up was kind of linking back to things that you've already known, but it was also setting you up to discover the first of the properties, which is the multiplication property. So our first theorem for today is if segments, or angles, would work for angles as well, are congruent, then their multiples are congruent. And that's the multiplication property. A little bit easier to remember, a little bit easier wording than our division property, or not division, than our addition property yesterday, right? So if segments or angles are congruent, then their multiples are congruent. That's the multiplication property. And then, you guys are so used to it. I'm not going to make you come up with that second one, but you probably got the idea, right? Same thing here. If segments or angles are congruent, then their divisions are congruent. Works the way, right? Same way. If I had given you that the big parts were congruent here and said, how can you tell me, and I knew that I had trisected it, and then you could tell me the little parts were congruent, that would be the division property. Now remember, the thing that made this work was that word trisect for each of them. If I didn't know that they were trisected, I just had some points on there, then it all falls apart because it wouldn't be x, x, and x, all three on the left here, right? These wouldn't all be x. It might be x and 5 and 12, and we don't know. It was that word trisect that split it evenly. So if you need to use the multiplication or the division property, either one, it has to say bisect, trisect, or midpoint in order to use these. Any one of those would mean splits it into congruent parts, and so that's when you can use either the multiplication property or the division property, but it has to have bisect, trisect, or midpoint in order to use those properties. But they are easier to remember and easier to write, so we like using them, I'm sure. So let's see a problem here. Here's a picture. You've got some angles going on. Notice you've got 2 angles marked with numbers. Actually, I should say 4 angles marked with numbers. 1 and 2 over on angle ABC. 3 and 4 over on angle EFG. That just helps you talk about them a little bit easier. So our given says angle ABC is congruent to angle EFG. Ray BD bisects angle ABC, and ray FH bisects angle EFG. Go ahead and pause the video and write down, what do you know about those pictures based off of that given? Think about your new properties. Okay, so first given was that the 2 big angles were congruent, right? This whole thing is congruent to this whole thing. Then it said that BD bisects angle ABC, and it said that FH bisects angle EFG. I have the word bisect. I have the word bisect. All right. So there were quite a few things you could have written down. Now, I want to kind of show you the difference between 2 things that you probably did. So you could have written angle 1 is congruent to angle 2, right? I could have written angle 3 is congruent to angle 4. Those are true. Those are true statements, right? But that's not the division property. This is the definition of an angle being bisected, right? If an angle is bisected, then it's split into 2 congruent parts. If an angle is bisected, then it's split into 2 congruent parts. That's true, but it's the definition of bisect. It's not the division property. However, if you had said, let's say, well, I know the big angles are congruent, and I know that both of them were bisected. So if you said angle 1 is congruent to angle 3, one from over here congruent to one from over here, that's the division property. Or you could have said angle 2 is congruent to angle 4. That would be the division property. Or you could say angle 1 is congruent to angle 4. Or you could say angle 2 is congruent to angle 3. Any one of these would be the division property. Hopefully you can see the difference here between the 2, right? All are true statements. And none of those were assumed from diagrams, so it's okay if you wrote all of them, but I want you to really be clear because that's something that gets mixed up quite a bit. So whenever you're using 2 that are on the same side of the equal sign, or not the equal sign, same angle, right? Same side of the angle, 1 to 2, that's the definition of bisect. That's just an angle being bisected. If you're going from one little part in one angle to one little part in the other angle, that is the division property. All right. So hopefully that helped clear up some questions about that. It also works the same for the multiplication property, right? So definition of bisect would be all in the same angle. If you're using multiplication, you're going from one to the other. Okay. Whoops. All right, so next thing we got to do, we kind of narrowed down our multiplication and division properties, kind of getting an understanding of them. Next thing we got to do is write a proof with them. I will tell you, this is not a short proof, but I think that you guys are getting the hang of it now. I think you can tackle it. So really remember just to make a plan, all right? There's a lot going on here, and really be looking for how you're going to use the properties that we learned today. Okay, so think of how that's going to work. So you are given angle 1 is congruent to angle 2. You're given that ray BG bisects angle ABF, and ray CE bisects angle FCD. Your job is to prove angle 3 is congruent to angle 4. Really look at that picture, make a plan, mark it up a little bit, and then start writing out your proof. You can check your answer by clicking on that link down at the bottom, or you could watch the video. I'm going to do it here in a little bit, but why don't you pause and see what you can do with your proof. Okay, I'm going to zoom in a little bit so I really have enough room to write. I might need to scooch over onto a different part. Let's see. Okay. Step number 1. Angle 1 is congruent to angle 2. That was given. So this angle is congruent to this angle. All right. Now I know that ray BG bisects angle ABF, and I know ray CE bisects angle FCD. I got that one already picked. Okay, so this is bisecting ABF. This is bisecting FCD. Okay. My job is to prove that angle 3 is congruent to angle 4. I'm going to highlight those two. I'm trying to prove these two angles right here are congruent. Now notice I use my highlighter. I don't know that yet. That's my goal. That's what I'm trying to get to. Sometimes it's easier if you see it in your picture so that you can make your plan a little bit. I know angle 1 is congruent to angle 2. I know those two big angles, ABF and FCD, are bisected, right? Now, bisected would give me, I would know for sure that these two angles were congruent. Like ABG and angle 3 are congruent because of bisect. But that doesn't tell me why 3 is congruent to 4. Same thing over on the left, right? I would know ECD is congruent to angle 4 because of bisect, but not 3 to 4. I have the words bisect though, and so hopefully, maybe I could use the multiplication or the division property since I have the word bisect. Well, if I was going to use multiplication or division, I'm trying to end up with small parts, right? So if I wanted to use the division property, I'd have to have the big angles be congruent in order to get to the little angles. Well, how could I get to this idea that these two big angles were congruent? Hey, ABF is supplementary to angle 1. FCD is supplementary to angle 2. And 1 and 2 are congruent. So I could go way back to 2 point whatever that was, 3, and use that theorem to help me get there on this one. All right, let's see. Okay, if I'm going to say that they're supplementary, though, first I need some straight angles. So step 2, angle ABC is a straight angle. That is assumed from diagram. All right, now that has a vertex right here at B. So that means step 3, I can now say angle ABF is supplementary to angle 1. If, step that has been said before, if two angles form a straight angle, then they are supplementary. So don't forget, If I'm going to use the word straight angle, I got to stick with straight angle. I didn't say 180 degrees. That's not something I can assume from a diagram. So stick with the vocab. And remember, if you're going to say that ABF is supplementary to angle 1, if you start your if-then form, if two angles form a straight angle, you got to make sure that's your little clue, your little hint. Hey, ooh, did I make sure I wrote that assumed from diagram step, right? So that's kind of your built-in safeguard to make sure that you've included everything. Okay, so I've got that supplementary step, but now I need a straight angle over here with a vertex at C. So step 4, angle FCD is a straight angle. And that is also assumed from diagram. You could say same as 2 if you want to. Sometimes when you see it written out like this, it's a little easier for you to understand what's going on. So I wrote it up, but you could write same as 2. All right, so now I've got another straight angle over there with my vertex at C. So then step 5, angle FCD is supplementary to angle 2. This one I'm going to say same as 3. If two angles form a straight angle, then they are supplementary. So I've got to, if I'm going to have 2 supplementary steps, I got to have 2 straight angle steps. So just be careful you've got it all. I already said that angle 1 was congruent to angle 2, so now I can use that that theorem, I should say, that we learned back in 2.4, I believe it was. And that is angle ABF is congruent to angle FCD. And the reason, if 2 angles are supplementary to, now are they supplementary to the same angle? No, they're supplementary to 2 congruent angles, right? Here it says supplementary to angle 1, here it says supplementary to angle 2. That's 2 different ones, not the same one. So, if 2 angles are supplementary to 2 congruent angles, then they are congruent. Okay. So I got those big angles to be congruent, my big blue ones that I have highlighted up here. So now I have the word bisect, but I haven't put it in my proof yet. So next thing I think I'm going to do is write down those 2 givens with the words bisect in them. So step 7 is BG bisects angle ABF. Given. And let's see. Should we rock this color? Step 8, CE bisects angle FCD. 8. Given. All right, so I have those 2 big angles are congruent, and I have bisect for each of them. I'm trying to prove that one little part of each is congruent to each other. So I'm ready to say it right now. You do not need to write down that all those little parts are congruent. All I need is the word bisect to know that they're split into congruent parts. That is something that the book kind of bounces around on. Sometimes they do it, sometimes they don't do it, and it gets a little bit confusing, and I understand that for you. So I want to tell you right now, we can go straight to after you have the big parts congruent and you have the words bisect on each one, you go straight to the division property. So my last and final step here is angle 3 is congruent to angle 4. And the division property was, if 2 angles are congruent, then their divisions are congruent. Okay, and I'm going to just make a little note here, right? Do not need steps with all little angles congruent. The book sometimes includes those steps. You don't have to. Too much time, too much of a chance to write something wrong, wasted writing, you don't need it. You just have to have the words bisect, and you have to have the big angles congruent in order to use the division property. Boom. That's it. straight to the division property. So again, that was a common confusion, a common thing that I answer a lot. It's a lot of times when I can tell that you're copying answers off the answer key is when you include those steps when you don't need them. If you're having some confusion about that, by all means ask. And if you ever include steps you don't need, it's not wrong. It's just wasted time for you. And also, if you write it incorrectly, then we can't give you full credit for the proof. So just be careful, right? Don't include things you don't need. Easier on everyone. All right, hopefully that proof went okay for you. That's it, right? Really understanding the difference between multiplication and division, kind of similar to, addition and subtraction. Remember, if you're starting small and you're proving something big, that's multiplication. If you're starting with big and proving something small, that's division. And don't forget, you got to have bisect, trisect, and midpoint. And then really understanding the difference for the division property, the difference between the definition of bisect and the division property is a hot topic for mistakes. And then just really how you write that in a proof. And that really wraps it up. I think I kind of just walked through all the lesson wrap-up things here. So hopefully now that you've seen those, you'll be able to use those in proofs and get a little better at it. Homework for tonight, page 91, you've got those 4 problems. Definitely, though, if you're getting confused, if you're getting some of them wrong, got to copy that from the answer key, definitely take a look at those optional extra practice and ask your teacher some questions.